We are going to discuss about return statement. So in the last class we have discussed about what is definition of a function, how to call a function and how to declare a function, and what is the need for a function. So today we are going to learn one more important concept which is named as return statement. The return statement is used to terminate the execution of a function, and it returns the control to the calling function. So when the return statement is encountered, the program execution resumes in the calling function at the point immediately following the function call. So it moves back to the actual program from where the function was called. So here the one programming tip what we are supposed to remember is it's an error to use return statement in a function that has void as its return type. So if we have a void in the place of a main function as a return value, then there will not be any return value. So it's a wrong thing to use a return statement in for void functions. So a return statement may or may not return a value to the calling function, and the syntax of the return statements can be given as a return followed by an expression. So the value of the expression, if present, is returned to the calling function. However, in case the expression is not included, the return value of the function is undefined. It is taken as undefined. By default, the return type of the function is always considered as an integer value. And for functions that have no return statement, the control automatically returns to the calling function after the last statement of the called function is executed. This is about return statement with respect to function. Now coming to the categories of functions, with respect to the value returned by function, the parameters used, the functions are categorized into 4 categories, that is function with no parameter and no return value, function with no parameter and return value, function with parameter and no return values, and function with parameters and return value. Now let us take up this one by one now. Now first we will take up function with no parameters and no return values. Here in this case of functions, both your main function and the sub function will be of the void type. So here they are also called as void function with no parameters. So in this category there is no data transferred between the calling function and the called function. So the called function cannot receive any data, and also the calling function also cannot send any value to the calling function. So you can see in this particular example, we have declared both main and the add subfunction as a void. So void main. So here your function is also called as void, and we are performing an addition operation with the void function. So here addition operation is performed in the function and the results also displayed in the function itself. So in this example, no arguments are passed to the function add, therefore no parameters are defined in the function header. So the results is displayed in the function only, and it is not displayed in the main function. So when the control returns to the main function, it just terminates the program. So there is no exchange of data between the main function and the sub function in this particular case. Next we'll move on to the second category, where the function will have a parameter but no return values. So here we have parameters, but both of them are considered to be again void here with no return values. So this is also called as void function with parameters. In this type there will be data transfer from the calling function, so the called function with the use of parameters, but there is no data transfer from called function to the calling function. Here as we can see, the input data are taken in the main function and parameters are defined here. So in the function we have the parameter, that is int a and int b. So parameter is declared in the function, but there is no return value from the function to the main function. So here just addition operation is performed and the result is displayed in the sub function itself. So results are not displayed in the main function in this particular category. Now the third type is function with no parameter and with return value. So in this category there is no data transfer from the calling function to the called function, but there is a return value which will be transferred from called function to the calling function. So here the function will return a value to the main function. So uh, here we are going to declare the main function as void, and the function will have the return value in the form of an integer here. So here we are calling a function as int add. So here addition is performed, so parameters are not declared here with in the main function also and in the sub function also, but there is a return value from the sub function to the main function in the integer format. Now the fourth category is function with parameters and return values. So in this category there is data transfer between the calling function and the called function. So when the parameters are passed, the called function can receive the data from the calling function. So when the function returns a value, the calling function can receive a value from the called function. So here parameters are available here both in the main function and in the sub function in the form of an integer. So we have declared the parameter as int a and int b both in the main function and in the sub function. So here inputs are read from the main function and the result is evaluated in the called function, and the called function returns the value of addition to the main function and the result will be displayed in the main function. So these are the four important categories of functions that we have based on the input parameters and the return values. Now before moving to the other part, we are supposed to know the difference between the two types of the parameters that is used in the function, named as formal parameters and actual parameters. The variables which is defined in the function header of the function definition are called as formal parameters, and they are also known as dummy parameters. So formal parameters, they receive the data from the actual parameters. So actual parameters, they transfer the data to the function. On the other hand, formal parameters in the function definition receives them. So the actual parameters and formal parameters must match in number and their data type also. But variable names can differ, but the data type and the number should match. So here an example is taken here where m and n, which is declared in the main function, is considered as the actual parameters, and the value a and b, which is declared as an integer in the sub function, which is denoted here with an arrow, is considered as the formal parameters. So formal parameters are declared in the sub function, actual parameters are declared in the main function. This is one common or the major difference what we must know when we are defining any function with respect to parameters. Now the important features or the factors that we are supposed to remember with respect to parameters are displayed here. So first we will discuss the features of actual parameters, followed by formal parameters. So actual parameters, as we know, they are defined in the main function. So these parameters are available in the calling function, and actual parameters, they send the values to the formal parameters, and actual parameters can be constants or it could be variables, and address of actual parameters can be sent to the formal parameters. So these are the features of actual parameters. Now on the other side, formal parameters are the functions or the variables. They are available in the function header or in the function definition, and formal parameters receive values from actual parameters, and these formal parameters should only be variables, they cannot be constant. This is the major difference. And if formal parameters contains address, they should be declared as pointers. So these are the main differences between the actual parameters and formal parameters. Now another important concept with respect to function is passing of parameters to functions. So data transfer between the functions can be achieved in any of these three ways which is listed below, that is pass by value, pass by reference, or pass by address. So let us take up this one by one. So first we will start with pass by value. So pass by value is a return operation where the value of the actual parameters are copied into the formal parameters in the called function. So here the formal parameters contains only the copy of actual parameters, okay, and pass by value makes the function more self-contained and it protects them against the accidental changes. So that is, the changes in the formal parameter does not make any changes in actual parameters. So actual parameter does not get affected by the formal parameters if we are using this particular technique where only value is passed. Now, pass by address, on the other hand, here what it does is the address pass by address, when a function is called, the address of actual parameters are sent. And in this case, formal parameter is function should be declared as pointer, because it is, we are dealing with the address, it should be declared as pointer with the same data type as actual parameters. So using these address, the values of the actual parameters can be changed indirectly. And the third type is pass by reference. So in pass by reference, the formal parameters are treated as alternate names for actual parameters. So any change in formal parameters imply there is a change in the actual parameter, but this technique is not supported in C, it is supported in C++ language only. So we'll be using the first two techniques if we are programming with respect to C language. Now to understand the first technique, that is pass by value, let us consider a code. So here we are taking a function called as an add function, which accepts the integer variable that is num and adds 10 to it. So we are adding 10 to it. So in the calling function, the value of num is considered as 2, because see here initially we are initializing the value of num to 2, correct, and we are performing an addition operation. Though we are here, the actual parameter is num, though the value of num before calling the function is 2, and here since the value is getting affected, the value of the number after calling the function is 12, and the value of the number num after calling the function doesn't change, it remains as 2. So only in the function the value will be changed as equal to 12, but in the main function it will be retained as equal to 12. This is, so here the actual parameter value is not changed, only in the function, in the formal parameter the value is getting changed. So this is the example. Okay, next is pass by address method. So here in this case we are taking two numbers, number 1 and number 2. So here the first number is and the second number is read in the main function, and it is displayed, and we are swapping the number, that is the number 1, whatever value it's there in number 1 is moved to number 2, and number 2 is moved to number 1 using a temporary variable. Next, call by value. So in call by value, called function creates a new variable. So the same example is shown here. So here it is telling you how the value is not affected. So this is again call by reference. Now we will take up scope of variables. Now in C, all constants and variables have a definite scope. So the scope means that the accessibility and the visibility of the variable at different points in the program is shown. So the various scopes for the variables includes block scope, function scope, file scope, and program scope. So first we will start with block scope. So block is nothing but a set of statements within the flower bracket. So a statement block is considered as a group of statements enclosed within open and closing curly brackets. So if a variable is declared within the statement block, then as soon as the control exits the block, the variable will cease its existence, and such a variable is also known as local variable and is said to have a block scope. So here as you can see, we have two variables, that is x and I. So here I am performing an operation where the value of x outside the while loop is displayed first, and we are taking a while for a condition I, and here the value is getting printed. Now you can see that the value of x outside the while loop is 10 and the value of x inside the while loop is 0. Correct. Similarly, the value of x inside the while loop is 1. The value of x outside the while loop is 10. So here we are printing the value of x in three different forms. So value of x before while loop, value of x within the while loop, and value of the x after while loop. So here the block scope is provided for the variable x. Okay, so based on the control what we have, the value of x gets updated according to the statement what is available within a block. Now function scope is applicable only with go to label names. So that is, a programmer cannot have the same label name inside the function. And program scope, if you want the function should be able to access some variables which are not passed to them as arguments, then we are going to declare those variables outside the function block, and such variables are commonly known as global variables, and hence global variables are the variables that can be accessed from any point of the program. So these variables are generally declared outside the main function, so they can be used by any block at any instant of time. Next, coming to file scope, when a global variable is accessible until the end of the file, the variable is said to have a file scope. Now, to allow the variable to have a file scope, we are supposed to declare the variable within the static keyword before specifying its data type. So the static keyword indicates that it has a file scope, and the global static variables can be used anywhere from the file in which it is declared, but it is not accessible by any other file. So such variables are useful when a programmer writes his or her own header files. So this is applicable only for creating header files. Now coming to storage classes, as I told, there are 4 storage classes which is available. The storage classes of the variable defines the scope and lifetime of the variable or function which is declared within the function. And in addition to this, the storage class gives the information about the variable or the function, and it is used to determine the part of the memory where the storage space will be allocated for that particular variable or function, and it specifies how long the storage allocation will continue to exist for that function or variable. It specifies the scope of the variable or function that is a part of the C program in which the variable name is visible or accessible. It also specifies whether the variable or the function has an internal or external or no linkage, and it specifies the whether variable will be automatically initialized to 0 or any other intermediate values.